We present Open3DIS Open Vocabulary 3D Instance Segmentation with 2D Mask Guidance. Open3DIS can perform instance-level segmentation on objects from a 3D point cloud reconstructed from a sequence of RGBD images, which has been annotated with semantic labels, instance labels, and superpoints. The Open Vocabulary 3D Instance Segmentation can segment objects at instance level by responding to any arbitrary text query in free-form text and any object properties. Closed-set 3D point cloud instance segmentation methods are limited in their ability to recognize a wide range of object classes due to the extensive training data required. Recent Open Vocabulary 3DIS methods have established reliable baselines but face challenges in accurately segmenting small or ambiguous instances, especially those belonging to uncommon classes. Prior work, OpenMask3D, uses a fully supervised backbone like Mask3D on 3D point clouds to generate class-agnostic masks. Each mask is matched with RGBD images via camera calibration and processed through clip to extract features, which are then compared using cosine similarity with clip text embeddings. The 3D instance segmenter, trained on closed vocabulary data, has limited capability in segmenting new classes with uncommon geometric structures, which hampers the performance of OpenMask3D. Our proposed Open3DIS give an input 3D point cloud and sequence of RGBD images. Different from OpenMask3D, we utilize 2D instance segmenters, such as grounded SAM, SAM, or scene, to generate high-quality 2D masks. These 2D masks are then processed through our proposed 2D guided 3D proposal module to generate class-agnostic 3D masks. 3D instance segmenter can be an independent 3D proposal generation branch. To facilitate open vocabulary queries, we introduce a pointwise feature extraction module designed to generate a dense, queryable point cloud that is featurized using clip. Our Open3DIS produces high-quality class-agnostic 3D masks, and featurized point cloud has the capability of generate instance segmentation, semantic segmentation, and instance retrieval using arbitrary input text queries. We will detail our proposed 2D guided 3D instance proposal module. Our 2D guided 3D instance proposal module takes superpoints and 2D instance masks as inputs and outputs class-agnostic 3D proposals. To create superpixels from original images, we group neighboring pixels into perceptually meaningful atomic regions, which are used to replace the rigid structure of the pixel grid. Similar to superpixels, superpoints are clusters of points within a 3D point cloud. These points are grouped together based on their geometric proximity and often their reflective characteristics. To lift 2D masks to 3D point cloud for every single frame. First, we use SAM to obtain a set of 2D masks of every RGB frame. Then, for each 2D mask, we project superpoints onto their image planes and calculate the IOUs with predicted 2D masks. Finally, we merge all superpoints that have sufficient overlap to create an initial 3D mask proposal. The corresponding results are displayed on the right side. After obtaining per frame 3D object proposals, we merge point cloud regions from different frames in a bottom-up manner. Agglomerative clustering is chosen to combine proposals from pairs of frames. The process is recursively called to form a binary tree until the highest level is reached, at which point we obtain the augmented 3D proposals from the 2D segmentation masks. We will discuss our proposed featurized clip point cloud. Our pointwise feature extraction module takes class-agnostic 3D proposals and RGBD images as inputs and outputs featurized point cloud. For each 3D proposal, we identify the top lambda views based on visibility, use multi-scale cropping, and then process the data through a clip encoder to obtain featurized point cloud features, ready for open vocabulary querying. We evaluate Open3DIS on 5 different datasets: ScanNet++, ScanNet 200, ArcitScenes, S3DIS, and Replica with average precision and average recall. We present OpenVocab3DIS results from ScanNet 200, where our method significantly outperforms previous OV3DIS approaches and rivals fully supervised methods. The results of Open3DIS on Replica and S3DIS datasets. Our method also achieves state-of-the-art performance with significant improvement. The class-agnostic 3DIS results of Open3DIS on the challenging benchmark of ScanNet++. Here we present some qualitative results on ARcitScenes. For ScanNet 200. Class-agnostic 3D instance segmentation on ScanNet++ using SAM. To summarize, we propose Open3DIS for open vocabulary 3D instance segmentation, achieving state-of-the-art performance on 5 different datasets by using 2 streams of 3D proposals generation. Future research on adapting Open3DIS for other 3D representations such as 3D Gaussian splatting would be an interesting exploration. That's it, thanks for listening.